In this video, we continue our discussion of section 11.1, working on vectors. So this video will mainly contain a bunch of definitions. This representation of V, so they're showing the one below, is to be in standard position. What standard position means is that it's centered at 0, 0. That's all it means. And then it goes to the point. This allows us to compare vectors if we just, since it doesn't, we just talked about in our last video that vectors don't live anywhere. They're just a direction and a magnitude. Well, if I put it in standard position, that would help me be able to compare vectors, add vectors, do a bunch of things that we're about to do. So standard position means that the initial point is at the origin. That's all it means. In the definition, note the difference in the notation between a component form. Okay, so this is in this next definition. It's a little out of place, that line. We have something in vectors we call component form. What component form tells us is the direction. So if I had a vector and I said the direction was 2, 3, there's my vector like this. This is called component form. Notice that these are angled brackets. They are not round. If you write them round, they are a point. It's no longer a vector. What this tells us, it gives us a direction. Up 2, or sorry, not up, right 2, mess it up right away, right 2, up 3, right? It tells us a direction. Now, there is a way to get a magnitude from this, and we'll talk about it here in a moment, but that is what component form is. The first one tells me the x direction, the second component tells me the y. So if v is a vector in the plane whose initial point is at the origin, whose terminal point is that, then the component form is there. v1 and v2 are the components x and y. If both the initial point and the terminal point lie at the origin, so it's just a point, then v is called the zero vector. How we note this, it sounds funny, or it looks funny, but it's a zero with a vector notation over it. It means a zero vector literally is just a point. So with this definition, there's a couple things that we should point out. If v and u, both vectors, are equal, then their components must be equal. v1 must be equal to u1, and v2 must be equal to u2. There's no other way for two vectors to be equal. They have to be the exact same thing, right? The procedures listed below can be convert line segments to component form or vice versa. So let's talk about what they're talking about here. We have a point, our initial point P. We also have a terminal point where it stops, Q. So we have an initial point and a terminal point. To find a vector, I just need to know how much did it jump from the first point to the second point. Well, how I determine that is I just subtract. If I want how much did it go from P1, that's right here, let me grab another color. P1, I want to know how much it went up from P1 to Q1, then I just subtract them, Q1 minus P1. If I want to know how it went from P2 up to Q2, I subtract those as well. So what we're doing is we're just subtracting the differences. We're trying to figure out how far did it jump from one to the other. All right, so this is the definition here of taking a terminal point and a initial point and finding a vector based on those. Right, so if we look at the distance formula, if you think about the way in that first video for this section, we looked at a vector on a graph and we had this vector, and then the best way to look at it for length was make it a right triangle, and it was 3, 4, and we found that this was 5. Well, that's just the Pythagorean theorem, which is the distance formula, which is right here. So how I find a vector, the length or the magnitude, right? Magnitude is what we're going to use mostly. Magnitude, I subtract my x's and square it, then I add it to my y's subtracted and squared, then I take the square root. Or if it's just a v1, v2, and they give me the vector, this just says square v1, square v2, add them together and take the square root. This is the distance formula. It's the exact distance formula. We are going to do this practically this whole chapter that we're going to do with vectors. We're going to do it every single section. So to find the magnitude of vector, that's how we do that. I'll give you an example down below. Number 2 here. Okay, so they gave us a vector. This says v being v1, v2. And it says, then v can be represented by the directed line segment in standard position from 0 to q. So notice they went backwards. That's all they did. The length of v is called the norm. That's another name for it. It's the magnitude or the norm. If the norm equals 1, then what we call that is a unit vector. Unit meaning 1. If you remember the dreaded unit circle, right? It's because it had a radius of 1. Unit means 1. So the unit vector has a length of 1. And then if it has a length of 0, that's only true if it's the 0 vector. There's no other vector that's not 0 that would give you a length of 0. All right, we have an example here. It says find the component form and length of the vector that has initial point 1, -4, and terminal point -3, 6. Let's call it v. That's what they called it. And it says we want to find the component form. So what we're going to do is you take your x of your terminal point, -3, and you minus it from the x of your initial point, 1. I do the same thing. Be careful with the second one. 6 minus -4, just like that mistake back in slope. I don't know if you remember the minus negatives. A lot of people make mistakes with those. So v then, the component form of v is -4 and 10. So this tells me a direction. It tells me if I want to follow along this vector, wherever I'm at. Remember, it doesn't live at a specific point. But if I wanted to follow this vector, all I would do is go left 4, up 10. Just like slope. It tells me a direction. They also want the length. Well, the length of this vector is the square root of the squares of each component. The square root of the sum of the squares. So, -4, I square it, and then I add it to 10 squared. So we get 16 plus 100, which is the square root of 116. We can break this down. I'm fine with an answer like that on a test. You don't need to break it down, but if you'd like to, because out of habit, and it does help sometimes, this is equal to 2 root 29. You don't have to do that. If you want a calculator that will do that for you, it's great. It does radicals. Look up a TI 30XS. It's like $20. It also will do something like this for you. Pi over 3. It'll figure this out. It'll actually tell you that this is radical 3 over 2. It'll spit that out for you. Do not get the one that has the 2. There's like one that has like Roman numerals. It looks like this. That one does not do that. All right. If you need a link or you're curious, just give me an email or text, and I can send you a link to Amazon or wherever your preferred is. So, okay, we covered standard position of a vector is just at the origin. We also covered that the component form of vectors, just the directions. We also looked at how to find the magnitude, which is in that gray box or weird color box, tan box in the middle. And then we also did an example.